Hey guys, I'm Gabe with The Ridge, and we're here with Mrs. Alvizo from the Science Department. Today we're going to be doing some awesome chemistry experiments. We have goggles and lab coats coming in right now. Welcome to Chemistry with Alvizo.
Woohoo! Okay, so this first one we're going to do, this person has a small head, is a pretty classic one called elephant toothpaste here. Gabe, do you want to mix it?
Sure.
Okay, pour it on in.
So can you tell us exactly kind of what's going on here?
So the idea of this reaction is there's soap down there with a chemical, and by adding this catalyst, it's going to cause the soap to bubble. Oh, and make
Big mess.
a big mess, and hence the toothpaste idea, right? That's what they call it in like elementary school and stuff. I don't know if you can see on the cameras, but it creates like a lot of steam, so it produces a lot of heat in this reaction as it just will bubble away for probably quite a while. But
Awesome.
there we go.
Cool. Okay, let's move on to experiment 2.
Okay, so for our second reaction here, let's bring our beakers to the middle. So one thing in chemistry that you'll notice a lot for those that have taken it or for those that will take it in the future is a lot of the chemicals we work with in chemistry often look quite like water. But when it comes down to it, they're not water at all. So we're mixing these two things that look like water together, and we should hopefully see quite a few different reactions with the same exact substance. Now, another thing in chemistry as we deal is you'll see a lot of things with color changes, because a color change helps us know that a chemical reaction has occurred. Our goal here, if you can't tell, is we're trying to make the rainbow. Let's see if we can get a good blue one here. And then our violet. Oh, that one's not as violet as it should be. Now, the cool thing with this is we then, where's our big container here? Actually, I don't know if I want to do that. Here's what we're going to do. If we then add, we'll go this way. So then we have another clear liquid, same thing, we can actually reverse it right back to water. So the way this reaction works, it's an acid-base reaction, and we're pretty much neutralizing and then unneutralizing it again. And the indicator that I put in there beforehand is what changes the colors. And you literally could do this all day long. Just go back from colors to clear, colors to clear. So
Awesome.
there we go.
Thank you. Let's move on to the next one.
Okay, so our third reaction here, one thing everybody loves, right, is when you get old enough to buy dry ice. That's a cool time in your life. So we get some dry ice here. So similar idea. We have, this is a base in this with an indicator, and so then we're going to add our dry ice, which will produce carbon dioxide. We'll go for 2. And in the process of it bubbling, so there's the CO2 coming out as it's bubbling over all over the place. The indicator will start to change as it produces, because carbon dioxide is acidic, and so it will make it more acidic. I don't even know if you can see with all that smoke, but it's starting to get a little bit lighter purple in there. And we can even let this sit off to the side if you want. And
Yeah,
we'll just
so
kind
we'll
of
come back to this.
Careful, it's going to be really cold. We can just let that bubble away while we keep going, and the color of it will just kind of gradually change.
Sweet. Okay.
Oh, there it goes.
Oh.
See green?
Back on over.
It changed right when we moved
From a
it.
purple to a green.
Good. And if we leave it, it might even get more into like the red, yellowish range if we kind of let it sit.
We'll come back to this. Oh, it's already turning red a little bit.
As soon as we try to move it, right, then it will change.
Okay, we'll come back to that.
Now, a similar thing with dry ice. And one of my things about chemistry for those that get to take it is you not only learn about these cool things, but you get like see it happen. And that's why I love teaching it, is because it has both sides. So we're going to make, so you can put that one on, Gabe.
Cool.
So we're going to make what I like to call ghost bubbles here. So all we're literally doing, this is actually really simple for people to do at home. I made this little contraption with pieces at Home Depot. Is you pretty much just need a hose that can pump out CO2. Let's get a few more pieces in there. And then we'll put the lid on. And then we can, so we're going to make the CO2 come out of my hose here. So then if I dip it in the water, oh, there's one. Let's see if we can get a bigger one. Slow down the flow here. Oh, there we go. So then we can get a little ghost bubble, and then poke it with the other hand.
That's way sick.
So this is actually one I love to do with like my little nieces and now my daughter at Halloween time as we make ghost bubbles, and it's pretty easy to do, but pretty darn cool at the same time.
So this is just dish soap and...
Yeah, so the beaker's just dish soap and water,
cool.
Literally like a bubble solution, and then all you need is just something to blow out your CO2. But you can like, literally kids, well, and even not kids, will play with this.
Teenagers over here.
Yeah, like for hours, right? You can just keep making ghost bubbles, and you can make like really big ones, and you can stick it straight in the beaker and then just like blow bubbles like crazy, stuff like that. So you want one more?
Yeah, sure. It's an easy one to try at home, but make sure you have a parent by dry ice.
That's true.
Don't leave it on the countertop, because I made that mistake and cracked the counter. So
there's one more, they'll just keep coming. Oh, there it goes.
Cool. Should we move on to the next one?
Yeah.
Sure.
You want to just
Sure.
put that bubbling by the other bubbly one? Okay. So our last one here is probably my favorite one to do of all time. So for those that are in my chemistry class, you've seen this one a few, but I don't think you'll be bored by it. One of my favorite things to do is to make hydrogen balloons, because of course, most people ask every day in chemistry class, are we going to blow something up?
Yes.
And yes, we are. So we're going to add some, where's our hydrochloric acid? Yikes. It's going to be important to make our hydrogen balloon. I don't know where it went. What do you want me to do?
I don't know.
We could do, let's see. Yeah, I don't know where it got put.
Well, might have to try that one again later.
Yeah, dang it, this one's the best. Do you want to, what do you want to do, Gabe? Do you want me to go grab some more really quick?
If you can
You
run
want to
really quick.
tell them some chemistry facts?
Sure.
I'm the track coach. Of course I can run quick. Okay, tell them some facts about chemistry and why you love taking it. Because you've taken it 2 years in a row.
Right. So.
Because he took it last year in general, and now he's taking it from me in AP chemistry. So what convinced you to take chemistry 2 years in a row? That's nuts. Nobody does
Gotcha.
that. I'll literally, oh, I'm hooked up.
We'll be back with that. Promise, a hydrogen balloon is way worth it. Pretty cool. So, like she said, I took chemistry, the general chemistry last year, and this year I'm doing AP chemistry. So, chemistry is a little bit hard, I'll be honest, but if you have an open mind and are really into it, it's actually really cool. As you can see, we kind of learn why these things happen, and literally everything around you kind of revolves around chemistry, and everything applies to chemistry, and chemistry kind of applies to everything. So, like she said, I'm in AP right now, and it's a lot more rigorous, so if you're up for the challenge, and I recommend taking general chemistry before taking AP. So if that's something you're up for and think that chemistry is pretty cool like I do, then feel free to take AP next year. We'll just wait for the hydrogen balloon. So with this dry ice here, so we've got sodium hydroxide in here, which is a strong base. So I don't know if you can tell, but it has turned a little bit red in the middle, kind of with like surrounded by green. But I don't know if she explained this earlier, but basically what's happening here is, so we've got the sodium hydroxide, which is diluted in water. And so then we put a universal indicator inside, which kind of allows us to tell the pH. So the pH kind of corresponds with the color, and we're back with the hydrochloric acid. So we'll get right onto that.
Okay, if anyone asks, I was not running through the halls while holding hydrochloric acid.
It's only a little bit dangerous.
That would not be a safe choice to make, but it's going to be worth it. Okay, here we go. Goggles back on. So this right here, shiny metal stuff, is zinc. Hydrochloric acid. Fun fact, hydrochloric acid is actually what's in your stomach, but not saying that this is safe to drink. So then we're going to put a balloon on top to catch it.
So what exactly is happening in here?
So in the reaction, the hydrochloric acid is reacting with the zinc, and stripping off the hydrogen, so it's like separating the chemicals. And so the hydrogen, is because it's a gas, is just filling up the balloon. A lot of people originally would mistake hydrogen for helium because they're very similar in both that they're lighter than air, so this balloon, well, we won't let it float away because we want to see it, but it does float. They're also both odorless. But the biggest distinction between hydrogen and helium is the fact that hydrogen is explosive. And if you put this next to a birthday cake with candles, you could run into some issues. So we'll let it get just a little bit bigger. The bigger the better, right? Well, those ones are still just bubbling away, aren't they? Okay. Another big thing that we study in chemistry, so a lot of chemistries we're studying different types of reactions and what happens and why they happen. And the funnest thing I love about it is just the connection of connecting what you see versus what you can't see. That's what's hard, I'll be honest, about chemistry, is you can't see the things happening, but it's cool to be able to learn about them and then connect it to what we actually can see. So, all right, that should probably be big enough for us today. Okay, I'm going to move this. I'm going to tape the balloon down so it doesn't float or blow away. Or should we tape that right here? Is that okay?
Yep.
All right. Okay. Are we ready?
I think so.
All
This
right.
is the grand finale. This is the blowing up stuff part.
Okay, Gabe, you might want to stand back.
Okay. Cover your ears, it's gonna be a little loud.
Ta-da!
Sweet. And that sums up our live. So, can you just tell, so you teach AP chemistry and general
Yes.
chemistry, so can you just tell us a little bit about your classes?
Yeah, so I teach both chemistries and it's super fun. Like I said, the thing about if you're considering taking chemistry, I hope you do. I think it's a great class that can prepare you no matter what, even if you're going into science or not, because learning about how the world works is an important thing. And being able to see it in action is also super fun. There's a lot of hands-on things in both classes that we get to do, from labs and demonstrations. I mean, that's why I teach it, is because of all the hands-on stuff. So it's definitely something to consider taking next year on your schedule if you're ready for it. Yeah.
Awesome. Make sure you guys don't forget to sign up for a chemistry class next year. Big thanks to Miss Alvizo for joining us today. And as always, thanks for watching, and we'll see you next time.
This thing's just like smoking. I'm so sorry.
No, don't even worry about it.